Okay, well, you have some material that I was able to give you for that. And actually, let me find some isochron articles for you as well from the same people.
Would you agree that the short time, like i.e. 50 years or less, that we've observed any radioactive decay is really pretty short to try to make assumptions over billions of years? I mean, do we have enough data to know if it's logarithmic, geometric, or linear going back into time?
It's not an issue of whether you have enough time. I mean, it's okay. Let's just I shouldn't say that. That's a factor, certainly, but it's also a factor of how precise you can make these measurements. If you have a precision in your lab equipment that goes out to like 20 decimal places, even if you only have a year, you can certainly get the decay rates into the ballpark of what they would actually be.
Correct, but you'd be getting a decay rate for that year. And if this is a totally random event, like they say, the breakdown of the molecule, how can
it's not totally random. It goes according to a Poisson distribution. It's like if you look at a particular atom, you couldn't predict when exactly it would decay. But if you have a group of atoms, you can predict how many of them will have decayed after a certain amount of time with a very high degree of probability. And that's what all these isochron things rely on.
Right.
It takes a little group of atoms, from different spots of the same setting plane, and puts them all together. And they've also done these isochron plots where they take rock from the Earth and rock from meteorites and do an isochron plot on those, and they get very similar answers, which they interpret to mean that the formation of the solar system corresponds pretty closely in time to the formation of the bedrock of the Earth, which, I mean, even you would probably agree with that. You just think it happened at a different time.
Right, 6,000 years ago.
What would be possible if these decay rates had drastically changed would be that these isochron plots would be showing time elapsed in some kind of relativistic sense. Because the issue is that these points on the plot remain on a straight line, and the line kind of tilts up and down, or it tilts up. If it tilts down, it means that something is screwed up, because it only tilts up naturally. If it tilted up, and the decay rates had all changed to do this, then it would show an age of like 4.5 billion years if it were only 6,000, because all the points would be moving at the same rate. You know what I'm saying? So it's actually possible that the Earth is young if these rates have changed, and the isochron plots, we wouldn't be able to tell from those. They would give us exactly the same data. That's why I'm saying the only option left is these decay rates have changed. But the thing about that is that every scientific paper or any scientist I've been able to find that's commented on this has said, if I understand it, that in order for these things to have changed, the fundamental laws of atomics must have changed too.
Well, you can, the articles that I just gave you, for instance, the Accelerated Nuclear Decay one by Humphreys gives dozens of secular examples where they have been able to change these rates and actually, rapidly decay material in laboratories.
Yeah.
So it can be done without, screwing with the physics.
But then if you do that, you're going to cause, well, I'll have to read about it, but I'm
You're talking about uniformly doing it, everywhere all at the same time with every element, right?
Well, I wasn't talking about that specifically, but that's a good point, is that if this did happen, it means it must have happened in just such a way so that the potassium decay series and the rubidium decay series all happen to give the same apparent ages, which is very mysterious because there's no real reason a priori to suspect that they would decay at these different rates just so that they would align like that. I mean, that's very
good point.
It would be almost like God were trying to trick us, to be honest.
Or there may be an as yet undiscovered, truly natural reason for it. Now, what about?
It's possible, but it looks so unlikely. I'll have to read what the creationists say about it and get back to you, but I just don't see.
Okay. Is the helium a problem then? The real lack of helium in the atmosphere for this decay rate? It's always producing helium. Where is all the helium?
Well, I've read a bit about that, and it seems like what the scientists are saying about this is that there's some kind of cycle that this follows on, and that we're kind of. I mean, if you're on on a sine curve, and you're at a particular point of it, and you look at the slope of it, it can be like up or down and make it look like it's been increasing or decreasing for a long time, and really it's about to turn around. If we waited a few more hundred or a few thousand years or something, maybe it would go the other direction. We don't know. That's the difference between like the helium in the atmosphere or the saline in the ocean, is that those things can be influenced by, causal factors that happen on the Earth itself. It doesn't require like a change in like the laws of the universe or like properties of atoms to cause it to happen. Like the helium can be going up and down just because of like maybe the sun has a cycle, right? Mm-hmm. And the radiation from the sun like creates helium somehow, like these radioactive particles like hit the atmosphere and create helium. I don't know. I'm just kind of guessing, but like that's the sort of thing that could happen. But it would require a very different kind of explanation for the decay rates.
I'm looking at an article titled Potassium Argon AGEN. I don't know what that word is, of iron meteorites. Planetary Science Abstracts, 48th Annual Meeting. They said 80% of potassium in a small sample of an iron meteorite can be removed by distilled water in 4.5 hours.
Right. I heard about that too, actually.
Yeah, I think, here's Canadian Journal of Earth Sciences, article called Potassium Argon Isochron Age of the North Mountain Basalt in Nova Scotia, published in Canadian Journal of Earth Sciences, volume 16, page 973. It says, and I quote, in conventional interpretation of potassium argon age data, it is common to discard ages which are substantially too high or too low compared with the rest of the group, or with other available data such as the geologic time scale.
Yeah, what I would say about this is that there certainly is a certain amount of bias in the scientists when they look at things like this, because they've already concluded, that there's a standard model that we're looking at, and if you find stuff that doesn't agree with it, you're first going to try to find if there's anything fishy going on to make it screw up like that before you just conclude that the whole thing is wrong. It's kind of like whenever you're, we have certain physics principles that we are pretty sure are correct, like the way that gravity works or electromagnetism. If you see some fluke occurrence, you're probably going to question the experiment itself and the measurement before you start questioning the theory. And I think that's mostly what these people are doing, these isochron geologists. And I think that's only fair.
Oh, yeah.
If they started finding massive amounts of these things that were just totally wrong and they couldn't explain it another way, then they suppressed it, then I would be a little bit suspicious that there was something going on. But I just don't see any evidence of that.
You could look into the helium diffusion rates in zircons, which isn't the amount of helium in the atmosphere, but it's retention of helium, which is supposed to be a slippery substance here. You can check that type of information out between all the different ICR geologists and all the secular geologists who are challenging them, and to this date they've answered pretty much all the major ones. So it's still very interesting. If you get on AOL Instant Messenger, I could send you these links here, as they're all pretty long, and I don't want to read them over the internet.
Sure,
but
I'll message you as soon as I get off.
Yeah, the new rate data supports a young Earth. It's number 360, INPAC article 366. 366 talks about helium retention in zircons, and they looked at the amount of retention done by the work of Gentry, and they figured it out. They did the math on it and said that 6,000 years explains this. They even show a graph right here to show the incline and so forth, and so there's a factor of 100,000 for the difference between 6,000 years and the evolutionist perspective of history. And it was actually predicted correctly with 6,000 years as being the age of the Earth, the helium retention in zircons today. So
the zircon issue is very sticky, and I don't understand enough about geology and mineralogy to really comment on that. I mean, I'm trying to read up on it, but it's just not my background. I will.
But the math is though. So I mean, you've got the math down.
Sure. Yeah.
All right, we got a break. Stay with us if you like, sir. All right, we'll be back in a moment, folks.